Communication and Networking online lecture series. Myself Rima Rawal from LG Institute of Engineering and Technology in the Department of Electronics and Communication. Today's topic is sliding window protocols from the unit number 3, that is data link layer. In previous session we have studied the elementary data link layer protocols. Now in this session we will see the different sliding window protocols. So let's start with that. So the sliding window protocols are basically of three types. So the major sliding window protocols are: first, 1-bit sliding window protocol; second, a protocol using go back N; and the third, a protocol using selective repeat. Okay, now in the first one, that is in the 1-bit sliding window protocol, as the name suggests, 1 bit size of the frame will be there, and the 1-bit sliding window will be used for this protocol. That means here the window size will be 1 bit. And according to that protocol, the data transmission takes place from the sender to receiver. Now the next is a protocol using go back N. Here N indicates the negative acknowledgement, or else you can say acknowledgement signals. So in this, the signal will have the transmission as well as the acknowledgement of the received data frame. The next one is a protocol using selective repeat. So as the name suggests, in this protocol we are going to repeat the transmission of the particular data frame for the selected frames only. So let us understand each of these in detail. The first one is 1-bit sliding window protocol. So in the previous protocols which we have seen in the previous session, the data frames were transmitted in one direction only. That means it was the simplex communication. So in most practical situations, there is a need for transmitting data in both directions. So one way of achieving full duplex transmission is to have two separate communication channels and use each of them for simplex data traffic in different directions. Okay, but if this is done, we have two separate physical circuits, so each with a forward channel and a reverse channel. That means one for data and another for acknowledgements. So in both cases, the bandwidth of the reverse channel is almost entirely wasted. So in effect, the user is paying for two circuits but using only the capacity of one. Okay, so now before tackling the general case, let us first examine a sliding window protocol with a maximum window size of 1. Such a protocol uses stop and wait, since the sender transmits a frame and waits for the acknowledgement before sending the next one. That means in this the window size is 1. So the sender transmits a frame and it will wait for the acknowledgement and then it will transmit the next frame. Okay, here the working principle is the data frames to be transmitted additionally, which will have an acknowledgement field that is of few bits length, and the acknowledgement field contains the sequence number of the last frame received without error. So if the sequence number matches with the sequence number of the frame to be sent, then it is inferred that there is no error and the frame is transmitted. Otherwise, it is inferred that there is an error in the frame and previous frame is retransmitted. Okay. Let us consider this diagram. Here window size 1 is indicated. So consider this a sender side and this the receiver side, in which the first case, that is the initial stage, when the size of sending window is 0. That means there is no window size mentioned over here. So the sending window size is 0, whereas the receiving window is 1. So this is indicating the receiving window. Now the next stage where the first frame has been sent. So here the window is indicated over here and same at the receiver side. In the next stage, when the first frame has been received, it will look like this. That's when this has been transmitted and it has received. So now the window will move to the right side. Okay, and this is when the first acknowledgement has been received. Okay, so this indicates the windowing or sliding window with the size 1. Okay, now next is a protocol using go back N. So go back N ARQ, that means automatic repeat request, provides for sending multiple frames before receiving the acknowledgement for the first frame. That means before receiving the acknowledgement of the previous frame, it will keep on sending the multiple frames, right? Let us see that here if the sequence number of the frame is an n bit field, then the range of sequence number that can be assigned is 0 to 2 raised to n minus 1. That means what? Let's say for example the sequence number of the frames that is 2 bit field. Okay, so here the range of sequence number that can be assigned will be 0 to 2 raised to n, that is 2 raised to 2 minus 1, that will be equals to 4 minus 1 3, right? So likewise with the n bit field, the range of sequence number that can be assigned is 0 to 2 raised to n minus 1. Okay, the sequence numbers are numbered as modulo n. For example, if the sending window size is 4, then the sequence numbers will be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 and so on. Okay. Next is a protocol using go back N. Let us consider this diagram. Here, assume that this indicates the transmitter and this indicates the receiver side. Okay, so here the transmitter is sending the multiple frames which is to be received by the receiver correctly. As you can see, the frame number 0 is sent first and it is received correctly by the receiver whose acknowledgement is sent. So this indicates ACK0, which indicates acknowledgement for the frame 0. Then frame 1 is sent, which is received correctly, and for that acknowledgement is provided. Now in this frame number 2, second frame, that error is detected. That means there is an error in receiving this particular frames. So before getting the acknowledgement, it will keep on sending the upcoming frames. So here frame number 3, 4, 5, 6, 7 and 8 are transmitted and it may be received by the receiver correctly, right? But here in this particular protocol, all of these frames will be discarded by the data link layer. Okay, and then it will start again transmitting from the frame number 2 where the error has detected, and it will keep on transmitting the entire frames likewise. That means it will start transmitting from frame number 2 and then it will again transmit 3, 4, 5, 6, 7 and 8, right? So it will transmit that particular frames again and providing its acknowledgement, right? So here these frames are discarded, which is the concept of protocol using go back N. Now the next one is a protocol using selective repeat. Okay. So a selective repeat protocol is also called as selective repeat ARQ, that means automatic repeat request. It is a data link layer protocol that uses sliding window method for reliable delivery of data frames. Here only the erroneous or lost frames are retransmitted while the good frames are received and buffered. So it uses two windows of equal sizes, a sending window that stores the frames to be sent and a receiving window that stores the frames received by the receiver. So the size is half of the maximum sequence number of frame. Okay. The selective repeat protocol provides for sending multiple frames depending upon the availability of frames in the sending window, even if it does not receive acknowledgement for any frame in the interim. So the maximum number of frames that can be sent depends upon the size of the sending window. Okay. Now the receiver records the sequence number of the earliest incorrect or unreceived frame, and if then fills the receiving window with the subsequent frames that it has received. It sends the sequence number of missing frame along with the every acknowledgement frame. The sender continues to send the frames that are in its sending window. Once it has sent all the frames in the window, it retransmits the frame whose sequence number is given by the acknowledgements. It then continues sending the other frames. Okay. Let us see by this diagram. This will be easier for you to understand. So we are going to consider the same case. This is transmitter side and this is the receiver side. Transmitter is sending frame number 0, 1, 2, 3, 4, 5 likewise. Frame number 0 is transmitted and received correctly, whose acknowledgement is provided. Similarly, frame number 1 is transmitted and received correctly. Then the error in frame number 2 is detected. So the transmitter will keep on transmitting the further frames, that is 3, 4, 5 frames are transmitted and received, which are buffered by the data link layer. That means unlike previous one, here these frames are not discarded by the data link layer, but instead of that the frames are buffered by the data link layer. So now when this will send the NAK2 signal, that means negative acknowledgement signal, it will retransmit that particular frame only. Then it will continue transmitting the frames for the next frame numbers. That means it will not retransmit the 3, 4, 5 frame. Instead of that, it will transmit the next consecutive frame and keep on transmitting like this. That means now the next frames 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 likewise. Whatever the data frames the transmitter has to send, it will keep on sending with the acknowledgement given back, right? So this is the selective repeat protocol, in which particular selected frames are only retransmitted. So these are the three protocols of sliding window protocols, in which first one was 1-bit sliding window protocol, second was a protocol using go back N, and the third protocol is a protocol using selective repeat. You need to understand the difference between these three, and I hope this is clear to you now. These are the references. The first one is your GTU syllabus, next is your textbook, and these two websites are very helpful too. Some of the content from this may be available on this. So this is very important and helpful. Thank you. Thank you for listening.